This is the last video of our chemical reactions series. In this one, we're going to be talking about the difference between reactions that release energy and then those that absorb it. So there are two names for these reactions. The first one is called endothermic, and the other one is called exothermic. The way I want you to remember this is that word therm means heat, and endo sounds like going inside, endothermic, versus exo, which sounds like exiting, right? So exothermic means heat exiting. That means that that's a reaction where the heat is released. So the outside is going to get warmer when that happens because the heat is coming out of the reaction, like a burning or explosion. In fact, that's what I want you to think about. I want you to think about explosion. Here, exothermic, think explosion. I mean, endothermic is the opposite because heat is going in. So heat in is literally what the word means. So think of a situation where the environment is getting cooler. Now, of course, the melting of ice isn't a chemical reaction, so that's not a good example to put here. But anything where the environment actually ends up cooler because the reaction absorbed energy. So, like I just said, endothermic reactions absorb energy while exothermic ones release it. That means that the temperature out around it is going to drop for endothermic, but rise for exothermic. Think explosion, right? Makes sense. So explosion and the opposite of explosion. That's how you think of it. So this means it's not going to happen spontaneously because it requires energy. So if it doesn't have energy around to provide energy for it, it's not going to happen. Versus an exothermic reaction, which could happen spontaneously since it gives out energy, it has energy to give. So that is more likely to happen on its own. Normally, you're going to see endothermic reactions be the kind where more bonds are broken than formed. That's why I said net bonds build. So that means reactions like synthesis reactions, where you're putting together chemicals, or reactions where the bonds that form are more complex than the bonds that get broken. The opposite is true about exothermic reactions. Those are the ones that are going to be destroying things, like the opposite of a synthesis reaction, like a decomposition reaction, where the bonds are being broken than formed, or the bonds which are forming are less complex than the ones that were broken. So that means you are losing potential, right? That's literally what it means. The reactants are simpler than the products on the endothermic reaction. So think of it as building a building. It's going to take effort. It's going to be hard to get this done versus an explosion, demolition, where the reactants were more complex than the products are. They stored more energy than the products do, right, on the exothermic reaction. So that means the endothermic reaction tends to be increasing order, while exothermic reactions tend to decrease order or increase disorder, right? So you think of explosion again. That also means, like I just said, that the products tend to be more complex in endothermic reactions, where they tend to be less complex in exothermic reactions, and therefore the reactants tend to be more complex in exothermic ones. That means, of course, that the reactants are simpler compounds, which store less energy in the endothermic, and the products are simpler on the exothermic. So as you can see, they're literally the opposite from each other. Last but not least, examples of this, if you think about photosynthesis, which is a reaction where it requires sunlight, energy, it has to be input for you to build a molecule of glucose, right? And then the pieces that come out of it, glucose, is much more complex than the carbon dioxide and water that were the parts that were the reactants. So the reactants are simpler than the products, which are like the glucose. Energy had to go in. You are building something. Perfect example. Same thing with, if, like, say your body is building a protein, right? Or you're building pieces of your body, growing. All of these things take in energy. Versus an exothermic reaction, like digestion, where you're breaking down food into smaller pieces and you're making it less complex. You're going to release the energy. It's going to be warmer on the outside. That's why your gut is warmer. You're going to have cell respiration, where you're going to get that glucose that's complex and break it down into pieces, like carbon dioxide and water. Or like a combustion reaction with burning, or like I said, an explosion. So these will kinds of things which are exothermic. And last but not least, the one that tends to produce energy or act like an explosion, make light, obviously is going to be exothermic reactions. So all the options you're going to see in the test are going to use words like the ones I just put in the slide here. The one thing I do want to mention, though, is that technically all reactions require a certain amount of energy to get started. Even exothermic ones, you need a little spark to get it going. It's called the activation energy. So the one thing that this graph does not show, it's a little simpler, meant for middle school students, is that in reality, you must go a little bit up before you can go down. You have to invest a little bit of energy always to get things started. So even the ones which are exothermic, which can sometimes be spontaneous, do sometimes need a little push to get it going, right? Think of it as fire. Once you get it going, it just goes and it feeds itself, spontaneous. But you need a little spark to get it going. So, or a bomb, right? You need a little spark, a detonation to actually get it to go. But then it releases all that energy. So I hope that makes sense. And that's endothermic versus exothermic. And that's pretty much everything you need to know about chemical reactions for the assessment. I hope you find this useful. And don't do anything that would make your mom proud.